Dear students, we'll continue the last class. Last class we are seeing about the flow meters. Today we'll continue from the flow meters. Okay, in last class we are seeing about the different type of flow meters. Today we'll see one by one in a pictorial manner the cross section view of each equipment, so that in a better manner you can able to understand. Okay, this how if it has been cut into a 1/4 or 2/4 like that thing, it will be okay. The whole device will look like, okay, one such flow meter, okay, is called as Venturi orifice meter. Okay, it will look like this. Okay, this is how this orifice meter will look like this. Okay, an orifice plate will be kept at the center, so that it restricts the fluid path. Okay, it converges and it gets diverges. Okay, so actual diagram of the orifice device, orifice flow meter, will look like this. Okay, this is the image of real time. Okay, made up of stainless steel, so that free from rusting and all those things and all. I told about at the center. Okay, there will be some orifice plates being kept. Okay, just imagine like a plate having a hole. Okay, just imagine a 10 rupee coin having a hole at the center. Okay, like that, it will cause the restriction in fluid path. Okay, restriction in fluid path. Thereby, it creates difference in velocity or difference in pressure. Thereby, difference in pressure we can able to convert into a velocity. We can able to convert into a flow rate. This is how a flow meter works, just by disturbing the fluid pressure. Okay. The actual image, okay, it looks like this. A plate having a hole at the center. Okay, a plate having a hole at the center where it converges and it diverges. Okay, don't think that the maximum convergence will be there at the dia of the orifice. Instead, okay, it converges further, then only it start diverges. That location where the further convergence to the minimum diameter or to the minimum area is called as vena contracta. Okay, it's called as vena contracta. Okay, these are the different type. Okay, each manufacturer will follow either they design a eccentric type of orifice plate or segmental, or they go for conical, edge, multi-hole, like that and all. Each device has its own accuracy. Okay, so the purpose of using all these devices is to make accurate value of a thing. Okay, and the next is about Venturi tube. Okay, Venturi tube. Okay, and before that we'll see the another device called as pitot tube. Okay, pitot tube, wherever we want to measure the point pressure, from the point pressure, okay, we can able to convert into a flow rate and all. Okay, that type of simple device is called as pitot tube. Okay, it measures the static pressure. Okay, anywhere in this device. Okay, and this about rotameter. This about the third one is about rotameter. Okay, actual devices will look like this. Okay, a float. Okay, this is the rotameter, a float suspending the fluid. Okay, when it is being connected. Okay, the difference between a Venturi orifice or pitot, okay, it can be in an horizontal or it can be in a vertical. Okay, whereas here, okay, you need to install this rotameter wherever there is an upward fluid flow. Okay, you can't able to install in an horizontal. Okay, you can able to install in a vertical from bottom to top floor, like that. Okay, where the suspending, okay, based on the suspending the float. Okay, this float is made up of some special type of plastics, or depending on the density or velocity of the liquid. Okay, for a range of this type of flow meters, okay, are being designed according to the range of fluid flow, according to the flow rates. Okay, from 100 meter kg per second to 200 meter kg. Okay, you need to install with respect to the diameter. Okay, if you go for a wider range, means accordingly the float specification will vary, diameter will vary, and so on. Okay, this is the common type of device which is being used in the industries and all. Okay, this is how the Venturi tube will look like. Venturi tube, another modified version of orifice plate, is nothing but the Venturi tube. Okay, this is how the Venturi tube, okay, the convergence and the divergence. Okay, the cross section will look like this. Okay, when compared to the orifice and Venturi meter, Venturi measures more accurate, where it overcomes the eddy losses and so on. Okay, so venturimeter and rotameter. Okay, these are the traditionally and wherever industries they use them for measurement and all. Okay, apart from that, depending on the usage, okay, other type of devices exist. Okay, one such device is a turbo flow meters. Okay, where there will be a turbine that rotates depending on the flow rate. Okay, just imagine a paddle wheel like a thing. So if a wheel rotates in a faster manner, okay, so according to the, if you keep any tachometer like a thing, like I can able to measure that the fan speed, okay, 800 revolution per minute or 900 revolution per minute and so on by means of a tachometer. Like that rotation of the thing can be measured by means of tachometer and all. This about turbine flow meters. Okay, the turbine. Okay, just imagine the turbines. Okay, animated image. Okay, just imagine the stainless steel. Okay, where the paddles or turbines rotates with some thing. Okay, then other type of device is called as target meters. Okay, there will be some bluff body or some inert body like a thing. So whenever there is a fluid flow, it gives some stress to the suspending. Okay, it can be a plate or some inert material. Okay, whenever there is a, like in a road, okay, if they want your to restrict your velocity or acceleration, they will put some speed breaker like a thing and all. Okay, like that there will be some hurdles. Okay, so depending on the flow rate, this gets deviated. This gets moved. Okay, it's a slanting or it gets, okay, it's a more flow rate. Okay, just imagine a hanging plate like a thing and all. If there's a more flow rate, more velocity, that okay, more, it gives some more pressure to the to this target. Okay, so thereby it gets deflected. Okay, according to the deflection, okay, there will be a calibration chart which measures the flow rate. Okay, and this about target meters. Okay, this how the target meters will look like, and you can able to see in a digital manner. Okay, nowadays all two-wheelers and four-wheelers and all. Okay, there won't be needles like a thing and all. Everything will be digitalized. Okay, this will be transformed, okay, in an electronic manner. Okay, and another important, okay, whatever we are seeing, whether it's a rotameter or target meter or okay, something is being suspended within the liquids. Okay, some hurdles are being given to the fluid flow, thereby the pressure drop will be there. Yeah, okay, and this is a special device called electromagnetic flow meters. Okay, the special about thing is, okay, where there won't be any hurdles. Okay, no device being kept in the fluid flow and all. Okay, it is called as electromagnetic flow meters. Okay, it's a very important, interestingly. Okay, if you see how it works and all. Okay, it has its own advantage and disadvantage. One such advantage which I told, you are not restricting the fluid flow and all. Okay, so how it works in the sense, there will be some magnets, north pole, south pole magnets in between that. The liquid which is having ionizing liquid is a very must condition for measurement of flowing fluid and all. If it's a pure water, distilled water, it won't have any ions. Okay, where you can't able to measure those type of distilled water through this magnetic. Okay, if it's a normal drinking water which may have some calcium or magnesium ions which gets ionized during its fluid flow. Okay, this magnetic flux gets disturbed because of this ions movement and all. Thereby it measures the magnetic flux is being disturbed. Once the magnetic flux disturbed, okay, and EMF is being produced. Based on the EMF, okay, it measures. We can make a note of measurement. We can make a note of quantity of liquid or volumetric flow rate or mass flow rate of the liquid. This is how the magnetic fields and so on. Okay, this is how the devices, okay, it will work and all. Okay, this is very important topic. Frequently they will ask for part C question or part B, draw and explain about the magnetic flow meters and all. Okay, next another device is like a vortex flow meters. Vortex in the sense like that of target meter. Okay, here also a bluff body or some inert body, so that you create some vortex. Okay, vortex are nothing but the stagnation manner you can able to create some vortex, thereby the liquid gets hold for a time, then it regains back to its normal thing. So with respect to the vortex formation, okay, there will be some transmitter, receiver and transmitter releasing, okay. So it makes a sound wave or electronic waves and all, thereby, okay, with respect to the waves, with respect to the vortex, it gets disturbed, thereby an EMF will be produced. Okay, this is about vortex flow meters. This is how the device will look like. Even though it looks like a simple, this costs more than a lakh like that and all. Okay, so depending on its accuracy, depending on its make, the cost will vary. Okay, likewise, another such of device like that of magnetic flow meters is ultrasonic device. Here also there won't be any restriction in the fluid. Okay, there is no blood body or something, it disturbs the fluid flow. Okay, so it makes an ultrasonic waves. Okay, for measuring. Okay, you would have heard this. Okay, for measuring the depth of the sea and all, they use these ultrasonic waves. Okay, they produce the waves, they send it and they receive it. Okay, with respect to the sending and receiving, okay, fraction of seconds and so on, okay, they can be able to measure the flow rate of the fluid. Depending on the flow rate, this ultrasonic waves gets disturbed. More the flow rate, more the disturbance. Less the flow rate, less the disturbance. Okay, this about thing. Then another interesting thing is about Chirolis motion. Chirolis motion in the sense, like whenever there is a liquid that goes, okay, there will be some fluctuation or vibration in the liquid. Okay, that motion is called as Chirolis effect and all. Okay, by means of that Chirolis effect, for example, okay, liquid goes in one of the tube and another, if there is no tube, if there is no movement in that means, so okay, there will be some to and fro motion or vibration or some fluctuation, some vibration happens. Okay, based on that thing. Okay, based on that movement in thing or like a vibration. Okay, you can able to measure the flow rate and all. Okay, likewise, different type of devices, mechanical devices like gear motors or okay, these are all comes under anemometers and all. Okay, and likewise paddles. Okay, the small paddle wheels are like paddles. Okay, by means of measurement of this rotation of the paddles, we can able to measure the devices and all. Okay, so with this I'll stop today. Okay, these are the, so far we seen different types of thing. Okay, depending on the wherever we need to use, accordingly we need to choose appropriate type of devices and need to be used in industries. Thank you.